Okay, so if you look at the learning goals, they have write matrices and identify their orders, perform elementary row operations, and use matrices along with Gaussian and Gauss-Jordan elimination to solve systems of linear equations. The whole point of this is right here. Use Gauss-Jordan elimination to solve systems. That's what we're working towards. Gaussian is part of the procedure. It's actually one guy. His name was Gaussian. He developed the procedure to solve systems of equations with more. It's more effective when there's more than 2 equations to solve. When there's 3, 4, 5, 6, and he developed this procedure. And then Jordan came along later on and said, "Well, if you did this going down, why can't you just go back up and have the answers?" So that's what we're working towards in this whole mess of stuff we're going to be doing. Okay, so when we have a system of equations, when we have 3 systems, if we have 3 variables, we need 3 equations. Okay, if we're going to have unique solutions. If we have 4 variables, how many equations do we need to have? 4. 10 variables, we need 10. Okay, so if we don't, so there's things that happen. So exactly one solution, we write our answer as an ordered triple or as an ordered pair. Some of you on your assignments were not writing your answers as an ordered pair in XY. You need to be writing your answers as in the ordered triple would have 3 equations. XY is what you should have been doing before, right? So if we had 4 equations, how many would be in my ordered set? 4, right? And it wouldn't be a ordered triple anymore. What's 4?
Ordered.
Quad, I don't know, a quad something. It'd just be the ordered solutions. We typically order them in alphabetical order. In the book, that when they have 4 variables, they do X, Y, Z, W instead of W, X, Y, Z. And I don't know why, but they do. But you typically write them in there. Okay, infinite many solutions, you would get down to the bottom being 6 equals 0 equals 0, 6 equals 6, negative 15 equals negative 15. That when we did our elimination or substitution, that was when I had infinitely many solutions, correct? Yep. Okay, in this case, when we do this, we're only going to get 0 equals 0. When it's infinitely many, we will not get the rest because you have to finish it out.
So we only write 0.
Well, you'll see when we are doing the procedure, it will only end with 0 equals 0 with infinitely many when you're doing Gauss-Jordan elimination. No solution, 0 doesn't equal negative 2, 7 doesn't equal 10, things like that, right? And what you'll have is this right here for the Gauss-Jordan elimination. It would be like 0 equaled something. The rest of these other ones are for like if we were doing substitution or elimination. Those are types of things we would see. Down here at the bottom are just pictures of that. If I have 3 equations, they all have to intersect at one point, don't they? And they intersect right here. See this one point that they all intersect? That is the one unique solution. Okay? A line would be infinitely many solutions, wouldn't it? Because how many points are on a line? Infinitely many. So if it's a line, there's infinitely many solutions. If we have a plane, it's also infinitely many solutions. And the next 2 pictures are no solution. Why are these no solution?
Because they don't cross.
They have to cross at like one point, right? And these have 2 here. Have you been temperatured?
Yeah.
Okay. So these here, they don't all intersect at one point, so it's not a solution. On the third one, the planes don't ever intersect at all, do they? They're parallel planes. So that's just a visual to see. So you're going to have an ordered triple or an ordered pair, because we're going to be doing 2 and 3. You're going to have infinitely many solutions or no solutions. Now, infinitely many solutions, we are going to have to find
Bye-bye.